Let's take a look at the inverse trig functions. First, beginning with some values. Number 1 here asks us for the inverse sine of 1/2. What this is asking us is what angle is the sine 1/2? If we turn it around, we could really say the sine of what angle would be 1/2. So what we're looking for is for that opposite side to be 1, the hypotenuse to be 2, which would force the other side to be square root of 3, giving us a reference angle of 30 inside the angle. Of course, we want to answer in radians, so we would say that pi over 6 is the answer to the inverse sine of 1/2, because sine of pi over 6 is 1/2. Let's take a look at number 2. We'll work inside the parentheses first. The arc cosecant of 2. Remember, arc is just another way to say inverse cosecant. So what we're saying here is the cosecant of something equals 2. Let's draw a triangle where the cosecant would be 2. That means that the hypotenuse would be 2, the opposite side would be 1, and again the other side would be square root of 3. So now we have an angle here, let's call it x, where the cosecant is 2. Now we are looking for cosine of that angle. So you can look at your triangle now and see the cosine would be the square root of 3 over 2. Finally, let's take a derivative with inverse trigs. Here in number 3, we're looking for the derivative y equals arc sine of x squared. Since we have an inside-outside function going on here, we'll need to use the chain rule. So we'll find the derivative dy dx by taking the derivative of the outside function here. Notice that we have something being squared. The derivative of that would be 2 times that something to the first power. Now we'll multiply by the derivative of the inside. So the derivative of the arc sine is 1 divided by the square root of 1 minus x squared. So our derivative, dy dx, would be 2 arc sine of x. All over the square root of 1 minus x squared.